Yeah, welcome to the Defibrillating Web Security talk. Hopefully by the end of this talk I'll persuade you that the technology we're using today for web applications is actually insufficient and it's actually very limited, and a lot of the past of computers and a lot of the ways in which we used to develop applications back in the 90s are actually affecting us currently and in a way holding us back, right? To kind of give you an overview, I'll give you an overview of current technology, right? What do we have today? If we think about it, every single injection vulnerability that we know of today on the server side boils down to strings, right? It boils down to us not being able to tell where certain strings are coming from, right? So if it's in SQL injection, we have a dynamic query, we interpolate a variable foo. The problem with that is that the foo variable can be coming from untrusted source, right? And when it comes from untrusted source, we get an SQL injection. If you open a file and the part of the path is attacker controlled, again, you interpolate the string and you concatenate strings, and if the string is untrusted, we have a vulnerability. If you think about it, you would say, well, actually, why don't we just ban, use dynamically constructing things? And it turns out that people do use these kind of dynamic expressions and concatenation and interpolation with trusted strings too, right? So you could have a constant, you could define a base path as a command line flag or maybe as some sort of constant, and you will still use that, and you will use that string to interpolate full file path, right? So the problem is that we are using strings and we cannot tell which strings are coming from where, which strings are trusted and which are not trusted, right? In addition to that, a lot of technology that we're using right now relies on you to keep that in your mind, right? When you're developing an application, a web app, you're writing an app, you need to keep in mind, oh, that particular variable is actually a constant and it's trusted, and that particular variable is untrusted, right? And obviously it's very, very fragile, right? Because when you have a new developer joining your team or someone else who has not worked on that particular piece of code coming in and trying to do something, they may not have that mental map of the state of each variable and where it's coming from, right? And now what we require you to do is we require you to keep that in mind, and when you do that, we want you to actually go ahead and manually escape things. And if you are doing SQL and you dynamically concatenating SQL query, which you shouldn't be doing anyway, but if you are, you have to keep in mind and you have to remember to actually escape manually that particular parameter. Or if we're talking about XSS, you have to take that value, and when you output it in a template, you have to go ahead and HTML escape it, right? So we want you to do it very, very manually. A couple of additional examples of how awkward our technology is XSRF, right? One of the ways to address XSRF vulnerabilities would be to potentially add a custom HTTP header, for example, but that solution and that approach is generally fragile, has been demonstrated by Kusa, right? So once you start caring about XSRF, you will actually realize that what you need is a, say, unguessable XSRF token, right? Once you get an unguessable XSRF token, you'll realize that you probably need to make it expirable too. And then you get into this whole awkwardness of the solution where you have a user using your application, they have an HTML form, there is an XSRF token as a hidden element, he opens another tab, he left that tab open because he's working on some big document or something. He was working mostly in the other tab, he relogged in, his session has changed, and that token all of a sudden became invalid. The minute he switches to the other tab, he clicks submit, he gets an exception that his XSRF token, for example, expired, which you as an application developer would have to actually handle manually. Right? Authorization is another very, very awkward tag that we're using today. If you have a database and you're using, say, a ID, a globally unique ID to query the database, every time before you can issue a query to retrieve certain entity from the database, you need to go ahead and carry out access control checks to make sure user has access to that, right? And all of that is manual. All of that you have to do by hand, and it's prone to errors, as has been demonstrated multiple times, where people will write a lot of code, and no one is actually blaming developers because they're writing hundreds and hundreds of lines of code. And they remember to put those access control checks or escaping things at certain places, but there will be one spot where they forgot, and that's all it took to completely own application and say dump the database out. So the technology we are using is actually pretty terrible. And at the same time, a lot of times when you see, I don't know if you've ever actually looked at application, you look at application, it's completely full of XSS bugs. For example, you go ahead, report it, you report 20 bugs, 20 XSS bugs in the application, developer goes ahead, fixes one, fixes second one, and then they think about, well, why don't I just come up with some sort of generic solution and automatically escape everything? And that's what happens, right? We tell people, we say, hey, you need to escape your inputs. After developer has fixed 5 or 6 or 7 bugs, he realizes I better automate it. Well, the developer is smart, and usually they are. They say, okay, why don't we automate it? And when you start automating, the most common approach that we see today is automatically HTML escaping everything. Now you bear with me here. This is not an XSS talk, right? I'm just using XSS here to demonstrate that the way technology is working together is really awkward and really difficult for for developers. So it's just really like 2 or 3 slides about XSS here, right? So the most common approach is to HTML escape everything. And there are a lot of subtle problems once your application becomes a little bit more dynamic and you start doing JavaScript. As an example, right? Let's say you have a template in which you are extrapolating a variable called lname. And you are lucky enough to have an Irish person register on your website, right? I personally think that Irish people single-handedly are responsible for discovering probably the most SQL injections and cross-site scripting bugs than any other security researcher ever has done, especially back in the day. So now in this particular case, if you are doing var foo equals O'Connell and you have a single quote and you're quoting this variable this way, there are 2 ways you can escape this. First way is you put a backslash in front of, well, there's more than 2 ways, but one of them would be to put a backslash in front of the single quote, and the other one is to HTML escape it. And when you HTML escape it, you convert it to ##39. In this particular case, if your solution, which is most of the current popular templating languages do, is they just HTML escape everything. In this case, when you HTML escape everything, you don't have an XSS bug, right? So it's all looking good, all looking pretty. The problem comes in once people start using that particular variable. For example, if you have an element, let's say you have a div, and you want to assign that value to div, for example, to display the name on top you logged in as this and that. If you're going to do that, usually the advice we give people is try not to use inner HTML, right? You tell developers, do not use inner HTML, because when you use inner HTML, what you will have is you will potentially have XSS if something is attacker controlled. In this particular case, if you are using inner text and you follow the general advice of the security industry, you assign it to inner text. And when you assign it to inner text, the text that's going to be displayed will be actually O and non-escaped HTML entity, Connell, right? Whereas if you start assigning to inner HTML, then it's going to be displayed correctly. You see what's happening here is that if you follow the general advice, your app is going to look ugly. And I'm sure we have seen a lot. How many of you have registered on a website, you go in, and there will be a backslash in front of quotes, right? When you're just looking at the site, you're not really doing it. So usually, by looking at what kind of entities are escaped, you can actually tell the history of the application, right? If you go ahead and you see backslashes and single quotes, what that usually means is that application has been owned via SQL injection at some point, and the developers decided to just overdo it and just escape everything on the input and just be safe, but then when they output it, there is still these backslashes everywhere. Or if an application is going to be showing you a lot of non-escape HTML entities, you know they've been bitten by a lot of XSS bugs in the past. Okay, so you're using that. That's one example. Second example, let's say you want to create an HTML form, and in that form you want to, in the add text editable field, you want to display and show to people their name so that they can potentially change it. If you're going to assign to the value, so in JavaScript, if you have an input element, it has a value attribute. If you're going to do t.value equals foo, and foo being our HTML escape variable, What you're going to get in the text field is, again, ampersand 39. It's going to be non-escape entity. And so what a developer has to do in this particular case, they have to unescape HTML entities. Does anyone know how to unescape HTML entities? You actually have to, the best way that people have come up with so far is to create a div assigned to inner HTML and then read it back, right? So it's very, very awkward if you're going to do it this way. The technology that so HTML escaping as a technology, as a default way of escaping everything does not work, because HTML escaping has to be done contextually, right? Very, very few templating systems out there are supporting this type of contextual escaping. What I mean by contextual escaping is escaping it correctly for the correct context. And the example above it was inside of the JavaScript variable assignment, which was single quoted. In this particular case, the escaper will know what to do. And Google has actually, most of our internal templating systems are using actually contextual escaping. A lot of it is actually open sourced. We have a Java escaper which can be plugged into different frameworks. And below, if you look at the contextual GitHub link, if you're using Rails and you're using JRuby, then you can use contextual, which will use the above Java escaper to plug into ERB or eRuby is what they're using, and to actually very transparently escape everything for you contextually. You don't have to do anything. You just need to include the our Ruby file. Other examples of very, very awkward technology, as I said, would be authorization, right? All of those checks are very much, authorization has not been really generalized, and it cannot be really generalized like HTML escaping can be. So we still have to do very awkward access control checks and to make sure that attacker cannot access values and data of other people. And the APIs that we currently design are all based around global IDs. No one is actually trying to figure out a way to make it really, really difficult to mess up access controls. One of the really good approaches to that would be to, let's say you have an API get data, a call called get data, and you have an ID as a parameter, as an argument to that particular call. Most of the code now will just use that particular API, retrieve the values, and then do access control maybe before or after to make sure there is access. Whereas, what if you integrated authentication credentials into that call? So what if it was get data, current user, and the global ID? In this particular case, if there is not even an API to retrieve arbitrary data, it will be very much difficult for people to mess it up. And you get extra points if that is even done automatically and credentials are injected automatically. As I mentioned, XSRF, very, very, very awkward. And another very interesting thing is assumptions verification, right? I don't know how much of Java development or Ruby or anything else you've done, but a lot of times, a lot of assumptions such as user has to be authenticated, user must belong to certain things. These things are usually implemented as interceptors, filters, etc., right? So they run before anything else in your application gets invoked. And then the code inside of your servlet or inside of your action assumes that user was authenticated and assumes that that happened. And a lot of times once your application grows, you start doing refactoring. For those filters, a lot of times you have to specify a URL path, and you specify, oh, if you go here, then this filter must be executed. If you go to some other URL pattern, then some other filter gets executed. And a lot of times you end up having bugs, authorization bugs, where people can access something where assumptions of that particular servlet or actions are not actually met. And filter, for some reason, was not executed, and user was not verified to be authorized or authenticated. So these are so-called, I call them assumption verifications. It's assert-style checks that you can put into your application to make sure, as a second line of defense, to make sure that if something goes wrong, if something gets refactored, and some assumptions no longer true, you could verify them. And if you're going to do that in your application now, you'll basically have a bunch of if statements in your code which will just pollute your code, right? Right, so that's the technology. Very awkward. Industry. How many of you are security consultants here? Please raise your hands. Sweet. So I guess you will have to raise your hand for this particular question too. How many of you have given application security advice in the past 6 months? Okay, so that's what, sweet. How many of you have ever written a web application that was used by more than 100 people at the same time? Okay, a lot less hands, right? So, and that's a little bit the problem, right? So what we have is we have developers who are writing code, developers who are writing features and creating different interesting things, and we have security consultants who usually are not very good at software engineering, let's be honest, right? If you look at a lot of security tools that are written, the code is shit, honestly, right? It's non-reusable, it's non-readable, non-extendable, it's full of hacks, it was meant to be used by these two people who actually understand it and they're friends, and anyway, so code is usually very terrible, right? And it's very difficult to modify or reuse that code. And then we have software engineers who are interested in writing software. They have to do a lot of things. They need to think about scalability. They need to think about features and all of those things. And security is just another thing that they need to address. It's just another item that they need to fix. So there is a gap, right? So we have people giving advice to software engineers, people who do not know how to write reusable software or how to do it well. Then we have people who are kind of interested in security, but they do not have the mindset of security researchers and consultants. Because we know that if you have one minor bug, don't try to argue and see if it's exploitable or not. Go ahead and fix it. It doesn't cost you anything. Whereas a lot of times with developers, you will have to persuade them to fix this minor bug. And we all know if you have a chain of minor bugs, as has been demonstrated in Chrome once at least, once you have a chain of minor bugs, you can actually get that to be a pretty critical bug if you sum them all up, right? So we don't have that intersection of people who have that knowledge and also know how to write software. I call it usually security engineering, right? And very few companies these days actually have a notion of security engineers. We have grown. Everyone has a security team now. But security team is mostly there, essentially like a security QA, security testing, right? You're given the app in the end, you find it's 3 XSS bugs, 4 access control bugs, you give people advice, please validate your input, escape outputs, all these generic things, and then you move on, right? And this gap needs to be filled, and this intersection needs to grow in order for people who know about security and who know how to write software to actually work on security solutions that are reusable and are easy to use for developers. And the industry as a whole right now is based around finding bugs, right? So obviously it's very logical, it's a business, companies are there to make money, and obviously finding bugs brings more money than solving classes of problems, because once you solve one class of problems, another class of problems, you run out of consulting engagements because people go, yeah, well, yeah, we already got that covered, so we don't really need you anymore, right? So the security industry doesn't want to fix classes of bugs, yet those bugs, those classes of bugs, especially in web apps, are relatively simple and relatively easy and relatively straightforward to solve from the software engineering standpoint. But again, since there is no financial motivation, security industry embarks on this really, really complex software engineering projects to address symptoms of the problems, right? So we have people going ahead and implementing web application firewall, where they will have to do a lot of very difficult things like parsing requests, making sure that how do they handle duplicate parameters, ensuring that the coding is correct, taking care of a lot of things, and then doing crazy things like injecting HMACs into forms and so this really, really complex software engineering problems to address symptoms, yet they don't want to fix the root cause. Another very good example is static analysis. A lot of companies are trying to work on that very, very, very difficult problem to essentially find bugs that we have due to a pretty crappy technology, essentially. So we have this super complex product to find bugs due to faulty tech. I find it a little bit funny. And another thing is, when I come up to you, let's say I come to you and I say, hey guys, I have the solution to all of your SQL injection problems, right? First thing you're going to tell me is, hey, I have the app I wrote 10 years ago. Actually, 3 of my interns wrote it. Is it going to work on that app? I say, no, it will not work on that app. You will have to actually modify your code and change it. That's it. I will be dismissed, right? My proposal will be dismissed because for some reason, the crappy app that was written 10 years ago is the way in which we are evaluating any sort of security things. And none of the new security technology gets any sort of adoption because of that mentality. Because we believe, for some reason, we believe that we have this crappy app and whatever someone will come up with, we'll have to work on that. Or if you have a, say, if your app is outsourced, if your primary app is outsourced, you have bigger problems than this. But if your primary app is outsourced, you will also ask me, well, your security solution, I have this app, it's crap. No one actually knows what they're doing in that app, but can you fix it? Which is why a lot of security industry is actually doing that, right? If you have people doing analysis, binary analysis, bytecode analysis, and instrumentation to fix these kind of apps. So what we have is we have crappy apps, legacy apps, holding back, essentially, the progress in web technology, and server-side web technologies that we have, because of all of those things that no one actually wants to modify anything, because when you outsource your app, you have no clue what you need to modify there in the first place, right? Another very interesting thing is a lot of mentality recommendations and approaches that we are seeing today are based on 90s mentality. How was it back in the 90s, right? You go ahead, someone hires you to do a pen test, you telnet, you guess the password, they have some crappy daemon, then you, I don't know, you do Perl, you print a bunch of characters into it, you find the buffer overflow, or maybe there's an integer overflow, you tell them, hey, you know what, all of your integer arithmetic, you need to make sure that there is no integer overflows. And I don't know, have you ever looked at how integer overflows are actually prevented in the code? It actually makes code really, really ugly and unreadable because there is a bunch of mathematical operations to make sure that there is no overflow. You multiply, and then you divide, and then you compare, and then you subtract depending on. And if the operation, if the operation is complex, that if statement is going to be even more complex. And back in the day, it was okay to say that, because back in the day there was no other tech. We had this C, and you could code in C. There was no binary instrumentation, and if it was very limited. No one really wanted to do it. And the whole mentality of, oh, it's okay for me to tell you to do a lot of work and not actually provide you with any sort of solution to make your life easier, right? And right now, we're also viewing everything that we're using, all of the web frameworks, all of the web technology as being constant. And I can see how if you're a consultant, you go to a bank, to your client, and you say, hey, you know what? Your web framework sucks. You should do this and this and this. Say like, well, it's not ours. It's an open source framework. We cannot really modify it. And then people have to work around all of that. So what we have here now is we have essentially the state of all of the web frameworks controlled by, maybe 100 people in total who don't even do it full time, right? They do it in the evenings, and then they get kids, and they have less time to do it, and those frameworks stall, and there is no progress at all. One thing I want to specifically call out, and that's going to be the rest of my talk, what I'm going to talk about, is strings. Strings are everywhere. Strings. Everywhere you look, you will see strings, right? Every single API, we take strings. A get parameter in Java, you get parameter name, the value will be returned as a string. You get header, it's a string. You create a database, everything is a string. And why are we using strings? Well, my theory is that because, again, this mentality from back in C, because when you code in C, everything is freaking char-buff, right? Everything is a pointer. You pass it around, you cast it to a struct, you do your little thing, then you cast it back, you write it out, and you're happy. Everything is essentially a string, right? And for some reason, we took that concept and we moved it onto the languages which actually have strong types. Like, for example, Java, to give you an example. Right? So in Java, we actually have types. So why can't we, instead of returning a string, return a type called HTTP parameter that holds a string inside? Sure. And we'll provide you all the methods to work with, like getting substrings, etc., etc. But when it hits some sort of sensitive API, the API will be able to tell, oh, wait a minute, that's actually a HTTP parameter, and I know it's untrusted. I should probably maybe escape it, right? So with types, the idea would be to come up with a type hierarchy, a generic type hierarchy with interfaces, abstract classes, etc., where you will be able to actually associate metadata with it. So you could say, oh, this particular piece of HTTP parameter maybe has been validated. And because it's a type, you can pretty much add any sort of typing, any sort of metadata to it. Or was it validated? Was it authorized? Was it authenticated? The problem obviously with it is habits. If you tell developer that you have to use HTTP parameter now, they'll say, oh, but I like my strings. But it's again very easy to overcome by having those kind of delegating methods in the HTTP parameter class. And another problem is existing APIs, which again can be addressed by writing a little thin layer on top of, say, JDBC driver and other drivers to fix it. Now, obviously, in ideal world, that's what we would do. And if any of you are doing that or want to do that, that would be great. But what I want to talk about is how we can add this type of typing information to strings without modifying the application, right? Kind of going along with the current way in which we assess security solution. This is going to work on my crappy app that my interns wrote, right? So this will, what I'm going to talk about. So remember, we can add types to, we can add types to a string by using tainting. Do you remember tainting? Perl had it, Ruby has it. Yeah? No one, who knows about tainting? Tainted, sweet. Who is using tainting? Okay, how big is your code? Is it 10 lines of code? The app in which you are using tainting? Huh? Couple thousand, yeah. Sweet, that's good. So it's a very small, you guys are the first people I see who actually use that. Even though I think you probably disabled it. What are some of the basics with taint tracking? This is a Ruby example. If you look at it, it looks really sweet. So what we have here is we have a foo variable. We say, hey, we're going to mark that variable as tainted, means untrusted. And then there's a method for us to check whether it's tainted or not. So in Ruby style, it's .tainted question mark. Is it tainted? It's true. Then Ruby has this thing called safe levels. There are 4 of them. And depending on the safe level, how high it is, there are certain restrictions that are enforced on certain tainted string and certain APIs and certain changes that you can make. So in this particular case, if you raise the safe level to 1, that means you don't want tainted strings ending up in sensitive APIs. For example, we raise safe level to 1, so no tainted string in trusted operations. If you do eval foo, it's going to throw an exception. And it's going to say, hey, that's untrusted string. Or if we try to open a file, and that's very interesting. You see how we are interpolating into TMP's full path, right? The taint is going to be propagated onto the final string, and the final string is going to be marked as tainted too, and file will throw a security operation error, right? That looks exciting. That looks awesome. Why doesn't it work? Why no one is using it? Why do we have still silly bugs in Ruby apps? Before we do it, we need to cover a little bit of the basics. So, hey, there is always a taint source. Taint source is the source of untrusted tainted data. Simple. In the web applications, it will be HTTP request, every part of HTTP request. There's taint sync, which is usually a security sensitive operation. So in this particular case, it could be a file operation, eval, any sort of backticks, and etc. Any sort of security sensitive operation. And another interesting thing is taint propagation. So we want taint to be propagated. So if we are concatenating 2 strings, one is untainted and one is tainted, we want the result to be tainted, right? Which makes sense. And there are several ways to interpolate and concatenate strings in Ruby. In all of those ways, taint will be propagated, all of those cases. So Perl has it, Ruby has it. 2 guys in the audience are using it. No one else is using it. Why? Why is no one using it? Well, so I will tell you why. It's inflexibility and the fact that it's very much binary. So let's talk about inflexibility. Usually taint tracking system, at least in Ruby, is part of a bigger problem. Or not a problem, but a bigger system. In Ruby in particular, if you look at safe levels, it sounds like they were designed to actually run untrusted code in your application. So in Ruby, if you put safe level 4, it will essentially separate the application, and there will be trusted and untrusted environment, and you will be able to essentially run untrusted code. Now, I don't know about you, but I think there are very, very, very few applications out there that allow untrusted code to be ran, at least as a part of the design, right? They can have bugs that allow you to run untrusted code, but as a part of intended design, very few of them do. So we have this really complex system designed to solve, say, problems of 0.1% of applications we have, right? Which brings us to another thing. Is because of that, they had to hard code a bunch of rules about what is sensitive and what is not. So for example, if you're going to enable safe level 1, file operations, eval, I think send, and other Ruby methods will throw exception if you put tainted data into them. But if you have a complex app, you may want to adopt only partially the tainting. You may be able to say, want to say, oh, I only want to track taint for file operations only, meaning only if tainted data ends up in file operations, I want you to throw security exception. In this particular case, you cannot do that because all of the logic is hard-coded to support the larger untrusted code system, untrusted code sandboxing system. And the binariness, right? So this particular example illustrates illustrates it really well. In this tainting system, code can be either trusted or tainted or untainted, right? So look at this particular piece of code. What we have here is we have parameter value, and we use it to do what? To open a file and then to display it back on the page too, right? In this particular case, if we validate the input for the file path and we say, oh, we want to make sure there's no traversal and it matches certain regular expression, etc., we'll mark it as not being tainted. But then when we output it later on, that data is lost, right? In particular, we have not validated it for HTML context in this case, which means that there's probably an XSS bug in there, right there. So because of that, because it's binary, reuse of the same value in different contexts is impossible. So how do we fix it? Well, we fix it very simply. We make it awesome, right? We make it practical, we make it configurable, and we make it contextual. How do we make it practical? So we need to remember that most of the applications do not have a problem of allowing people run untrusted code in a secure way. So what we need to do is we need to design a system which will apply to majority of applications these days, which is a standard web application, server-side component, which processes some data and outputs it and spits it out in a template, right? And we try to obviously solve the problems that applications have. And we need to make it configurable. So what we need to do is we need to let you configure what's the source of untrusted data. Because in a lot of systems, I think Perl, for example, environment variables are considered to be tainted. They will be considered untrusted. Whereas in a classic server-side application, you trust environment variables, right? Because it's your trusted environment. So we want to let you choose taint sources and taint sinks. We want you to say, oh, this is my sensitive API, and I want you to make sure that if tainted data ever gets to this particular API, whatever it's doing, it's application specific, I want you to throw a security exception. And the untainting, how do we mark strings being from tainted to untainted? How does this transition happen? We need to specify it. And then we may have to make it contextual. Introducing Gravizapa, really cool name. But it's runtime contextual taint tracking. What it means is that it tracks taint at runtime, and it allows you to specify whether this particular input is safe in which context, in say file context or HTML context or SQL context, in different contexts. And we have prototypes implemented in Java and Ruby. So it's contextual. So what that means, the way it's implemented is that if it's tainted, if a string is tainted, it can never be marked as untainted, ever. Once it's tainted, it's tainted. But what you can do is you can mark it safe for a particular context. You say this string is untainted, but I have validated or sanitized it to be safe, for example, for HTML or for file path. And it's configurable, meaning there is a configuration file in which you will specify what's the source of the data, what's the sink, and how they all tie together. And I'll show you an example. It's really interesting. And the cool thing about the Java and Ruby versions is that it requires no changes to the application whatsoever. It uses really cool new facility in Java called instrumentation, and I'll talk about it a bit later. So Java version is implemented by an intern at Google, George Dupre. Yeah, he's actually from Tasmania. And it uses Java's class file transformer. What Java has, in Java 5, they introduced this thing where you can create your own Java agent, and you can create a class file transformer, and you register it. What JVM is going to do, because before, in order for you to instrument any sort of bytecode, you actually had to go and mess around with class loaders and make sure that your classes get loaded through your class loader, which instruments everything. Here, you don't need to do that. You just specify a jar, and you specify a method which transformer will call, and then for every class in the JVM that is about to be loaded or that's already been loaded, the bytecode is going to be supplied to you for instrumentation. At this point, you can take that and instrument it the way you want and add any sort of code you want. There are a couple of limitations. Well, one limitation is that you cannot add new fields. There is a limitation. You cannot add new fields, and you cannot modify, say, if it's a final or if it's a public member, you cannot modify that. But you can modify code of any object or of any class, including JDK class, GRE classes, the standard library. One of the in Java, instrumentation in Java is interesting because if you start looking for Java instrumentation, you will see that a lot of people have attempted it. A lot of them go the way where they basically patch rt.jar, which is a native jar that contains core classes for GRE. They go ahead and modify the class in there, and then they start run the JVM, and then it crashes, right? Because again, we're using strings for everything. JVM has done a lot of work into making sure that strings are working really, really fast. So, and part of that is it natively assumes that certain fields and certain methods are at certain offsets when it does jumps natively, and if you start adding stuff to it without JVM knowing, it leads to basically crashes. And so if you look at implementations for this, people will say, oh, it only works on IBM's GRE, it doesn't work on Sun's, etc., etc. So Java 5 agents. So very simple. All you have to do is you start your application with Java agent argument, and you supply your jar. There's really detailed documentation, and then your agent is going to be called with bytecode of every single class in JVM. And there is a really cool library, because doing bytecode by hand is pretty cool, but there is a very much easier way of doing that. Is using ASM library. ASM is this essentially a de facto standard for bytecode instrumentation. Using this library, it's very easy for you to read the bytecode and modify only certain parts in which you're interested in, right? Sweet. How do we track taint? Do you remember that in Java, strings are immutable, right? Which means once you create a string, you cannot actually modify it. And I also told you that there is a restriction on adding new arguments to a string class. So you cannot really add new field, which will be called taint or something. You cannot really do that. If you look at the string class, there is a very interesting structure. There is a char array of value, there is an offset, and there is a count. Count represents the number of the lengths of the string that this particular string represents, and offset. You may wonder, why the hell do they need offset and count? Well, the reason for this is because Java's strings are immutable, which means that once you create a string, you cannot do anything to it. So it's safe for them. If you have a long string, foo, well, foo, very long string, and then you call a substring on that, what they can do is they can create a new object, new string object, which is backed by the same character value array, where they just adjust the offset and the count. So you can have two different string objects backed by the same character array. This makes it really fast to do substrings, etc., because in this case you can just adjust the offset, etc., to make it fast. Now, so as an example, If you have a string that says Cummins is the best drink ever, with offset 0 and count 27, if you call a substring on that, what they're going to do is they're going to create a new string object where offset is going to be 7 and count is going to be 20. Right? Now what we did is, in order for us to track taint, what we need to do is we need to find a way where we're going to store the taint data. What we did is we simply put taint into the character array. And what we are doing is we're simply adjusting the offset and count. When we do that, we can store the taint data and it's completely invisible to the application. Application cannot see it. We're using reflection to get access to the value array, to put the value in there. So that means once you put it in there, the application will actually never ever see it. But you can still access it and have a look at it. What we store in there, it stores a taint marker, which says that this particular string is tracked by us, and it stores contextual safety bits. Meaning, remember I told you earlier that this system allows you to mark something as being safe for a particular context. So those bits are stored in the little bit mask where we mark certain bits, we allocate bits for, say, HTML. It's all done dynamically, and we mark them as safe. Now, sources and sinks. If you have a source, you may wonder, well, what do you do? How does it exactly work when you instrument stuff? Let's say you have a get parameter method in the HTTP request object. What we're doing essentially is, in the end, right before it returns, we inject a call called taint.mark as tainted parameter value, and then we return that value. If it's a sink, for example, a Java IO file class, in the constructor, if you specified it and configured it, we inject and instrument a check to do taint.checkTaint path, and file path is a context. So because in this particular case, we're working with a file context, so what it's going to essentially do is going to look at the value that we have in there. If the file path bit is not set, it's going to throw an exception, throw an execute exception, or log an exception, depending on how you configured it. And taint cleanness. A lot of times when people will ask you, oh, well, if you do taint tracking for strings, the biggest problem is characters, because a lot of times what you're doing is people will go ahead and look at the string character by character. And because we don't have that data, we cannot really track taint based on characters. We cannot really do it. And the problem comes into play where you look at HTML escaping functions, for example, or SQL escaping functions. What they are doing is actually taking the input and they look at it character by character by character, escaping necessary values as needed, right? And then in the end, they construct a string and return it. So what we do here is, if it's a taint cleaner, we say that we don't actually care about characters, we don't actually bother. If you're going to configure a taint cleaner in a configuration file, and I'll show you config later, and you say, oh, HTML escape method is actually cleaning the taint, we actually do not care what it does. All we do, we assume that the return value of that particular method is the safe and clean value, which is how most of the HTML escaping and SQL and any sort of escaping is implemented. So what we do is, in the end, we simply say, return taint set safe for HTML, the return value. It may look very difficult in code, because you may wonder, well, how the hell do you do it in code? Do you parse Java? Actually, no. In bytecode, when you look at bytecode, it's very, very easy in bytecode, because in bytecode, all these return values are pushed onto the stack, operand stack, and they use a special bytecode called a return. So what we do is essentially, we already have the return, the final return value on the stack, so we simply instrument that and get access to that and do things. So it's a lot easier in it. And then the taint propagation. Obviously, no tainted tracking system is actually good unless you propagate taint. In this particular case, most of the classes are instrumented in very straightforward case. If you do something, if you call to lowercase or some other method, we're going to instrument that and make return value tainted too. That's very straightforward. Another thing is the concatenation like this. If you try to concatenate strings in Java with a plus, what eventually they get compiled into by Java compiler is actually string builder code. So the concatenation above is going to get converted into new string builder, initial value, dot append, dot append, dot append, and then two strings. So what we have to do is essentially just instrument string builder class to propagate taint. And here's the configuration. First, we specify the taint source, I know it's a little bit confusing because we're using this Java's internal representation of class names. It's mostly for convenience in use with ASM library. But what we have in here is we say HTTP servlet request implementation class. The get parameter, which accepts string attribute and returns string value, is a taint source. Then we specify that sanitizer class, and it has a, say, sanitize path method, which accepts a string and returns a string. We say modification type with taint set safety, so it's essentially a cleaner, and we specify a safety tag called file path. And in the end, that's a sync. We say our file reader, if in the constructor, the first argument of the constructor is tainted, and it has to have safety of file path. If it doesn't have the safety of file path, it will throw an exception. As I said, bytecode is a lot easier than Java code, so a return makes it really, really easy. This facility, Java instrumentation facility, is actually very, very, very powerful because it lets you do a lot of things that you cannot really do easy in other languages. And you can use it to implement a lot of stuff, authorization, accessref checks. You can do assert style checks that I was talking to you about. You can simply dynamically instrument your servlets to add all of those checks, and they will not be in the code, but they will still fail when some assertions are not true. 10, sweet, yeah. And Ruby version, yeah. Ruby Gravizapa, we implemented it. In Ruby, it's a little bit trickier because strings are mutable. When strings are mutable, that means that you can actually modify the string inside of it. So taint propagation rules become a little bit more complex because you need to think about cases where you have a tainted string, but in the middle of it you write untainted string, or more complex is when you have a safe string and then you write another string that's safe for different contexts. When they say for two different contexts, they actually, you have to handle that. We monkey patch string and etc. in Ruby, but the problem is that in Ruby, you cannot really monkey patch everything because Ruby promises, right? Ruby's promise to you is that, hey, we're a very dynamic language, blah, 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 you can do anything you want. But once you actually start instrumenting stuff in Ruby, you actually cannot instrument a G sub exclamation mark. Because if your regular expression is using capturing groups, then things like $1 are not going to get propagated. So it actually breaks applications if you instrument G sub. And another really crappy move by Ruby is that you cannot monkey patch interpolation. String interpolation, you cannot tap into that. Which makes you wonder which language is more dynamic, right? Because in Java you can do both very easily, actually. One thing, because you cannot hook into interpolation, what I did, I just patched JRuby with a very simple call, where if there is a method called pre-append, it's going to call that method. Ruby, idea with Ruby Gravizapa was to implement taint, more like a proof of concept for taint tracking, potentially pitch it to Ruby 2. So if you guys have any sort of connections with Ruby 2, you drink beer with Mats sometimes maybe, please mention this so maybe we can integrate it somehow in there. The Java Gravizapa needs a little bit more testing. It's a very powerful tool. Once a couple of things have been, couple of issues have been ironed out, we will eventually open source it for people to use and improve. So that will be very exciting, I think, when that happens. I'm done. Thank you. Do you have any questions?